Hello everyone. In today's video, we will continue our FPGA tutorials by designing and implementing a multiplexer. A multiplexer is a device that selects one of several inputs and forwards it to a single output line. So, we are planning to design a 4 to 1 multiplexer, but first we need to design a 2 to 1 multiplexer because in this diagram that shows the 4 to 1 multiplexer is actually 3 2 to 1 multiplexers, and the 2 to 1 multiplexer can be represented by this diagram of logic gates. In today's tutorial, we are not going to write a structural code for the 2 to 1 multiplexer, but a behavioral one. And I will leave the structural code for connecting these three multiplexers to make a 4 to 1 multiplexer. Let's get to it. Alright, I will be starting with showing some diagrams. First, I will show you the truth table of the 2 to 1 multiplexer, which is we have an input is called S. This is going to select which input we are going to output. If it is 0, our output is going to be X. If it is 1, is going to be Y. We are going to write a behavioral code, which that means we're going to use an always statement and a case. But first, we need to define our inputs and outputs. So I'm planning to make a 2-bit width multiplexer, 4 to 1 multiplexer. I will make the module here 2x1 multiplexer in module. Alright, let's define its input and output. As I said, 2 bits. We have the input X, the input Y are 2 bits, and we have the input S is a 1 bit, and the last thing is our output. It's going to be output register, the same 2 bits. It is 2 bits as well. And now let's write the behavior of our multiplexer. To start, we need an always statement. Between the brackets, we just gonna write here a star. We're gonna have a star in between the brackets. And then we are going to use a case, which is going to check what the value does S have. So S is going to be between the brackets here. And don't forget the end case. So to write a case in Verilog, you will just, for the S here, it can be 0 or 1. So let's have these cases. 0. If it is 0, our M is going to be equal to X. And if it is 1, our M is going to be equal to Y. Well, this is for the 2 to 1 multiplexer. Now, as I have mentioned, we are going to make a 4 to 1 multiplexer, which I will right now show you how to connect these three multiplexers to make a 4 to 1 multiplexer. Let's define the inputs and the outputs for the main module, which is going to be almost the same, but we are going to add, according to that diagram on the screen, the 2-bit inputs. I mean, we have U, V, W, and X. These are the 4 outputs. All of them are 2 bits. And now for the selection line, it's going to be 2 bits as well. but the first bit is going to pick between U and V or W and X. And then the second bit is going to pick between the output of the first multiplexer or the second output of the multiplexer. So if it was let's give it an example. If we have the selection line is 1 0, 1 is the most significant bit, we are going to select here W, right? Let's define the input of S. It's a 2-bit S. And the last thing we have output M. It's going to be 2 bits also. Alright, let's continue. You might see that I made a little modification here in the code. This way won't give us error. According to the diagram that we have, we are going to use the multiplexers here, the 2-to-1 multiplexers, to make a 4-to-1 multiplexer. For the first multiplexer is going to be the inputs are going to be U and V, and the first bit of the selection line. And for the output here, we are going to add something else, which is wire. It's going to be 2 bits as well, 2 bits. We will have N0 and N1. These are going to be the outputs of the first 2 multiplexers. So the first multiplexer is going to be N0, and I will just copy this. I'll change this to MUX2. The inputs are going to be W and X. The selection line is going to stay the same. Here is N1. Alright, now let's go to the third multiplexer, which is going to have the outputs of the first 2 multiplexers as an input. So it's here going to be N0, N1, and the second bit of the selection line. And for the output is going to be M. This is for the Verilog code for the design. And now we will write a test bench to simulate and check if this multiplexer actually works or not. To write a test bench in Verilog, first we need to have a test cases. I will list them on the screen as a table for the inputs and the outputs that we must have. Alright guys, now we are going to write our test bench. First, we need to define the inputs that we are going to test for this module. Inputs for which is they are going to be U, V, W, X, and S. And we are going to use wire instead of output. And now we are going to call our main design, which is named MUX. Name it MUX1. We will just give it all of the inputs and the output, U, V, W, X, and S. And then we have M. Okay. I forgot a step. You need to include the design, which is mux.v, before calling this main design. Let's continue. We can use an initial block to give the cases that we are going to use as inputs to monitor that and check for the output. I will initialize the U, V, W, and X as this in the same order. They are going to be 0, 0, 1, 0, 1, 0, 1, and 1, 1. So U is going to be equal to 2-bit 0, like this, and VX, X, 1, 1, here, and then the input that we are going to make a change on is going to be the selection line. So if that selection line goes different, we must get a different output. For example, if we had it 0, 0, the output must be U 0, 0. Or if it was 1, 1, the output must be X. So let's set that to be 0, 0, like so. And then we can make jumps between each input, so we can monitor that change. To do that, you just use the tag here and you give it how many picoseconds you want. I will just say 40 picoseconds and then semicolon. And what is going to change for us is the S. I will now just give it a random value. I will say just 1, 1. And I will copy this like that. Alright. I will now I will just give it different values. We are going to go to Model Sim and test our design. This is the starting windows of Model Sim. But first, before we try to compile the design and simulate it, we need to go and change the directory. You can see the command here, which is cd, and then you just give it the directory that your project in. After that, you go to compile, and then compile. We'll compile the test bench. Just hit yes. We didn't get any error or warnings. To simulate the design, we'll just go vsim work and the name of the module, which is MUX TB. We have got the windows, and here we have the input and the output. We can just hit run here, or for example, we can go down there and say run for 200 picoseconds. Well, let's zoom fill and review the result. We can notice that the simulation shows that the design is working for us. Here the S selection line is 0, 0, and the output is U 0, 0. The same 1, 1, the output is X. And the output here, the same thing. And here is the same. Now our design is working. Let's assign the pins and then program the FPGA and test it on the FPGA. Alright, now we are going to analyze the design so we can assign the pins. But before that, I will explain what we are going to use so we can present the inputs and the outputs. The first two switches, which means switch 0 and switch 1, is going to be for the U value, and for the V value, we're gonna have to use switch 2 and switch 3. For the W value, switch 4 and switch 5. And for the X value, switch 6 and switch 7. And for the last two switches, I'm going to use switch 8 and switch 9 for the selection lines S1 and S0. And the first two red LEDs, LED 0 and LED 1, are going to represent the result, or which means the output of our multiplexer. So for assigning the pin, I'm going to use the same way I did in the previous tutorial, which is going to assignments and then pin planner, and I will get the locations from the user manual. It's easy, you can just go to the website of your FPGA and you will find there the manual, and there you will find all the pin locations so you can assign them for the FPGA. I will do that and be right back. After we have assigned the pins from the user manual, we're going to close this window and then recompile the whole design. So after the compile, we will program our FPGA and test it out. I will be right back. Alright, we have compiled the design successfully. Now what we're going to do is program our FPGA. So we go the same way we did in the previous tutorial. Go to Tools and then Programmer and connect your FPGA. After that, Auto Detect and then our board here. Click Yes and then change the file to the output file SOF. Check the program/configure and hit Start. After that, we are going to look at our FPGA and test the design on the FPGA after we have programmed the design. Alright, here we do have the FPGA. Alright, let me just explain a little. I have already set the switches as I did in the model sim. The first two switches are going to be U, V, and then the other two will be W, and then X, and the last two will be for the selection line. So this set to 0, 0, 1, 0, 0, 1, and 1, 1. Right? To test that, we're going to change the selection line. Let's do it, for example, to 0, 1. Let's see what the two LEDs will result. Okay, we have got a result which is 0, 1, which is the third option, the third input. And now we will try a different thing. Let's try 1, 0. We got 1, 0 in the LED, the second input. Now let's try to get the last output, the last input. Here we got 1, 1 on the output, which means our multiplexer is working on the FPGA.